Okay, it's going. All right. Can you all hear me?
Yeah, we can hear you.
Sweet. Thank you. Okay. So yeah, welcome to this CSE 230 final exam review. So for the survey you guys took, so a lot of people were wanted to review for the data path related questions. Yes, they want to review on this, and some people also want to review on the stack and the UR, and then there were a few that wanted review on the load word and the store word, but not too many. So I'm going to try to focus most of my review on these. So I'll have some slides, and at the end I have a Kahoot with some practice questions. Okay. Yeah. So load word. It's a load word instruction. It's actually a pseudo op. As you guys know from the data path module, it's actually, yeah, it's two instructions because the immediate field in the load word instruction is only 16 bits. And it takes 32 bits for a full word. So it requires two instructions to do the load word. So that's why it's a pseudo op. Okay. And then store word. Yeah, so it just allows you to write to a memory address. I remember Professor Marr, a way to remember it he described is that just think of RAM as being like the storage, the place where you're storing, like the larger memory where you're storing to. So that's how you remember that store word is you're sending something to memory address in RAM, and then load word is you're loading from storage. If that makes sense. Okay, I don't know. I'm not sure if the people who were confused about load word and store word had specific questions, but yeah, if they do, they can ask them, or if anyone had any questions. But if we're good, I'll just move on. Okay, I'll just move on. Okay, branch disassembly. So this will look pretty similar to some slides Professor Marr had in his exam review. That's because I think he did a pretty good job covering it, just the process or the procedure of determining the delay slot, and then like the the mathematical steps you take to get the target address. So I think you did a pretty good job covering that. If you guys want, I can go through a practice problem, just kind of showing you, but if not, I can just move on. Or if you guys had any questions. Okay, I'll just keep going. Yeah, so, yeah, exactly. Yeah, this one. Yeah, so this slide is on jump disassembly. So it's fairly straightforward. It's a little bit simpler than the branch disassembly, but it's just you take the instruction value, and then you take the last 26 bits of it, and then you shift it to the left by 2 bits. And then you just add that to this hex 10000000 value. That's like the base. Okay. The jumps for negative numbers. Okay. I don't have a question prepared for that. there a problem prepared for that? As for negative numbers. Sorry. Yeah, I don't have one prepared for that. But yeah, for negative numbers, you would just well, yeah, I don't think. Yeah, for the branch disassembly, if it's a negative number, or if the offset is negative, then you just do the two's complement. So you just flip all the bits and then you add one. For temp disassembly, I'm not sure how that would work. Just move on. Yeah, sorry. Yeah, so for the stack. So the stack, it's a fundamental data structure. It follows the FIFO policy, which is first in, first out. You would think of it as dispenser. That helps. It's in memory. It's the reverse of an array. So instead of starting at a smaller address and moving to a larger address, it starts at a larger memory address, and then it grows upwards towards smaller addresses. So if you think of the largest address being on the bottom, then it just grows upwards towards the smaller address. And then we have the special register that points to the top of the stack. And then we have push and pop pseudo ops that they for push, it moves the stack pointer up and it adds to the stack, and then pop moves the stack pointer back down, and then it takes whatever value was there out. Important thing to remember is that you always have to initialize the stack. You can do that with this instruction here. And then it always starts at the largest address in the PLP architecture, which is at hex 10 and then 5Fs and the C. Okay, any questions about that? Okay, I'm gonna keep going. Okay, the UART, it stands for Universal Asynchronous Receiver/Transmitter. It does serial communication, which means it only has one wire to send data in any direction. We have several special registers that it uses. The command register, which if we send it using stored, if we send it a clear status, mask, then it'll clear that, and then it'll reset the status register. And then we can read from the status register to determine what the state of the UART is, like whether it has a new character or not. And the bit for that is also at the one position. So that's one to the left of the rightmost digit. The receive buffer contains whatever the most recent character is that we received, and so we can just use load word to take that and put it into a register. And send buffer, yeah, that's where the PLP processor would store a character that it wanted to have sent by the UART. I don't think that we've really covered that in this class. That's not going to be on the exam or anything. Okay. This is all review. I mean, you guys for this. Yeah, so the data path. So yeah, you guys had a lot of questions about this. I think, so just to start, there are three types, right? The R type, the I type, and the J type. Well, jump type, yeah, and immediate type, and also the register type. And they're all 32 bits. I think you guys will probably want to review on this one the most, just because there are so many different scenarios. For like, just for setting all of the control signals. So what I would suggest is that for the exam, it is going to be timed. So you're going to want to minimize the amount of time that you spend looking up. That you spend looking up, like, which control signals are like, yeah. So I would suggest having like a crib sheet. And on that crib sheet, you could have something like this, where you describe all the different situations where you would have the different control signals on. So let me just go through these. So for the reg destination signal, that would be high when it's an R-type instruction. For the jump branch instruction, that's pretty evident. It's just whenever you're doing a jump or a branch instruction. For the mem read, the signal is high just whenever you're reading from memory. Mem to reg is whenever we're writing from memory to register. So for example, load word. And these are just examples. This isn't like comprehensive. There might be other instructions that use these or have the signal high for them, but load word would just be an example. ALU op would be on whenever we have an ALU operation to perform. It's like when we're doing an addition or a subtraction, or also calculating an offset. For memwrite, we'd have it on when we're writing to memory. So for example, we're doing a store word instruction. And then ALU source, it would be on whenever we're sending an immediate into the ALU. So for example, that would be for like, add IU. And then for reg write, it would be on whenever there would be resulting data that needs to be written back into a register. So, load immediate or a load word or an add U or an add IU. Any questions about that? Okay. Oh, I got one. Yeah, it'll be uploaded. Yep. No problem. Okay, I'm gonna keep going. Okay, this is just for reference. Yeah, so another thing that you could have on your crib sheet that would probably be helpful for you is to have the data path of certain instructions. I think he said that he wouldn't be having you do any like full data paths on the final exam, which is good because they're paying, but I think that'd be good for you to have, just because you learn a lot that way, and it's good to have the examples for reference. So you can see here, I took these out of the video that he shared with you guys. And it just shows all the control settings for the different instructions. Yeah. So it'd be stuff like from the computer organization exam. Exactly. Yeah. Yeah, so it's good just to review the data path and kind of walk through it and like figure out all the different scenarios that you could be faced with, just because there's so many different options. So let me just, so for the ADU, or for the ADU, not ADIU, the ADU, you would have the reg destination on. Right, because you'd be Right, because it's an R type instruction, right? Because you're using 3 registers here. And then you'd have the ALU op because you're doing an ALU operation, you're doing an add. So that would need to be on. And then you would also be, you're also writing to the register, you're writing to register T0. For the dub instruction, you just have jump. That's pretty straightforward. All the other ones would be the signal would be low or would be off. For the branch shift equal, obviously you'd have branch would be high. And then ALU op would actually be high just because it would be computing, the ALU needs to compute the offset. So, or no, sorry, that's not right. It's not the offset. It would be, it's doing a comparison, right? So that's why you need the ALU, because it's comparing register T0 to T1. And then store word, you would have the ALU operation, which would be because you're doing the offset, the 12 in front of the address. That's you'd have to compute an offset for the address for that. So you would need the ALU op, and then obviously to store words, so you're writing to memory. And then ALU source, I think is right. You have an immediate the offset that you're sending the ALU. So that's why ALU source is on. Any questions about that? Okay, I keep going. Okay, so yeah, like I was saying earlier, just some tips. The exam is timed, and so you're gonna want to minimize the amount of time that you spend on each problem. The best way to do that is to practice, and so you can know the answer automatically just when you see the question, and so you don't have to spend as much time figuring it out. So the key would be to be going faster. My favorite for doing that is just have flashcards, because if you look at the answer, if you look at the question and you already know the answer, then it's easy to know that you're ready. Because you're like, okay, I don't even need to look at the answer. I already know it, and it's a good way. Yeah, it's a good way to know. Great. So those were all my slides. Yeah. So like I was saying, I put a Kahoot together. Hopefully you guys are familiar with that. So I'm gonna, okay, let me, dang it. Bar is gonna, okay. Okay, I'm gonna start it, post it. So for people who'd like to participate, just go to, yeah, Kahoot, www.kahoot.it, and then enter this game pin to join, and then we can start that. Let's give you guys a few minutes to do that. Okay, I'm gonna start it in just a little bit. We ready? All right, I'm gonna start. Okay, yeah, it just goes. Okay. Okay. Yeah. So, um, it's pop. So that means that we are popping something off the stack, which means that we're taking something out of memory, which means we would want to be using a load word, right? And then with the pop and the pop and the push pseudo ops, it always does it always moves the stack pointer first. So it always does the add IU or the add IU first. And then it takes whatever the address was or whatever value was in the address um, and puts it into a register. Okay, does that make sense for the people who missed it? Okay, I'm gonna go next one. Okay, hills on top. This is a data path question.
When are we likely getting this recording? Like, will it be appearing tomorrow or will it appear today later? Like, what time you think?
Nice. Okay. Yeah. Okay. So okay, let's go on next. Did you guys want me to explain that, or do you want me to just go to the next one?
Yeah, it'd be great if you could explain it, just to make sure.
Okay, I'll just go to the next one. Oh, sorry. Oh, no, I can't hear you. Uh, wow. But you guys can hear me though, right? Ah, shoot. Sorry, guys. I could probably post it today. Sorry, I don't know why I can't hear you. Um, yeah, sorry. Just message me through the chat, please, because I can't hear you guys. Okay, excellent. Okay. Yeah, so for this one, you actually have the call pseudo op, right? So you could either so if you have less than 13 instructions, or sorry, less than 13 registers that you're trying to save, then it makes sense just to push the registers onto the stack manually, because it saves on overhead. But another way, the other option you have for doing a context switch is to do is to use the call sudo op, which just does it all automatically for you. Does that make sense? Oh, okay. Yeah, so context switch. So I think you talked about that like when he was talking about the step with the stacks. I think that was like the second, third module. The context switch is where when you're jumping to a function, you need to save certain registers. So like you save all of your T registers and then your S registers as arguments. So that when you jump to the function and then you return, you can pop all of your saved registers off of the stack so that you have all of the data, that you had before. Yeah, all the data that you had before you jumped to whatever function you jumped to. Does that make sense? Yeah, yeah, yeah. It's related to the save and restore. What's your question, Anaf? Oh yeah, yeah. No, you can do it manually as well. Okay. Yeah. So context switch. So it's like if you're like programming in C, if you jumped, if you jump to another function and then you jump back from the function, um, the values in all of your um, the values in all of your variables, they're all the same, right? And it's the same thing with this. If it, if you jump to another function, um, you need to push all of your registers onto the stack so that when you return, you can pop all those registers off of the stack, and so that way they're unchanged. Does that make sense? Yeah, so the reason it's false is because you don't have to manually push the registers onto the stack every time. You can use the call sudo op. Yeah, the call sudo op does it all automatically for you. Yeah, no problem. Okay, next one. Oh, hills on top. Nice. So this is actually a little bit of a trick question. You can actually use both and also and I. You can use either one. Right. Cool. Any questions about that? Or, okay, I'll just keep going. Sorry. You're asking how do you use and? Yeah. Yeah, okay. Okay. Yeah, if you use two registers, then that's when you would use and then I would be if you had an immediate that you were using as the mask. You can do either way. Okay, next one. Oh, shade. Okay, so this is like we were talking about earlier with pop. Um, yeah, so it always does it always increments it first or decrements the stack pointer. And then after it does that, it does the store word. Right, and we're doing store word in this case because it's push, so we're putting a value into the memory. Um, and so the reason, okay, so sub IU is actually isn't an instruction, and the reason for that is because add IU is because instead of using sub IU, you just use add IU, but you use negative numbers. If that makes sense. So you just use instead of doing a sub IU with 4, you just do add IU with -4. And then we're doing -4 instead of, so we're decrementing instead of incrementing because this is the stack, remember? So it grows towards a smaller number. So that's why we're subtracting because we're moving up towards a smaller number, if that makes sense. Okay, I'm gonna go next one. This is a data path. Okay. All right, yeah, so for this one, just, yeah, so in this case, so we're doing an add u. So in this case, we're not doing anything with memory, right? So we don't need the memory, the mem to reg. We're doing the reg destination because um, right, because this is an R type instruction, right? So we're using the third register, and then the ALU source. Yeah, we're not using that because we don't have an immediate. We're not using an immediate. Okay. Yeah, yeah, 3 register instruction. So that's why we're doing the reg destination. Okay, any questions about that? All right, I'm gonna keep going. Oh, Lewis is still on top. Nice. Okay, most of you got that. Were there any questions from people who missed it, or? I'll just keep it. It happens. Sorry, Trent. Okay. Looks like most of you got that. Looks like some people were picking ALU source. In this case, yeah, in this case, the ALU source, yeah, would not be on because, or would not be high because, uh, wait, check. Oh, it's ALU op because we're doing a comparison, right? It's a branching if equal. So that's an ALU operation. A comparison is an ALU operation. So that's why the ALU op is on. It's off if you're not doing an ALU operation. So I think like for like a, actually that's a good question. Yeah, I'm not, let's see, when would it be off? Because it would be on for load word and store word 2, I think, because of the offsets. Um, so yeah, that's a good question. I think it's on most of the time. I'm not really sure which ones it would be. No, actually, no, it would be off for jump. For a jump instruction, it would be off. Yeah. Okay. And okay, I'm just gonna go. Okay, yeah. That was an easy one. All right, next one. Yeah, so it looks like most of you knew. You cleared the status register by writing to the command register, and you don't write directly to the status register. You can only use load word to load from the status register. All right. Okay, and that was it. Hill took third. It's like Lewis was first. Thanks, guys. That'd be fun, right? If we had the final just like in this format. Get a lot more fun. Yeah, so I realized I did actually have my mic off. So if you guys can talk if you want, if you have any questions. That was the end of my review. Yeah, thank you all for coming.
Thank you.
Yep. Shwari, I could probably put out an announcement with these questions.
Yeah, maybe something like a module page or something that would be really helpful.
Yeah,
Like,
yeah, sure,
yeah.
I can do that.
All right.
Yeah.
Thank you so much. Have a great day.
Thanks, you too.